Welcome to Science Conversations. I'm Kaysie Vokurka. How accurate is radiometric dating? Joining me to discuss part 2 of this topic is Dr. John Ashton. Welcome to the program, Dr. John.
Hello, Kaysie.
Dr. John Ashton has written a book entitled Evolution Impossible: 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. And we'll be referring to chapter 10 of his book in this program. So, John, there are many different radioactive isotopes that can be used to test and date rocks. If people use a number of different isotope testing for the same sample, what kind of results can we see?
Right, okay. Well, this is quite an interesting area. When we look at dating rocks, of course, as you say, depending on the minerals, there are a number of different methods that we can use. And it's quite fascinating what the results are. But I think one of the important areas to look at is that initially when we compare the dates of conventional dating from the fossil record, for example, the traditional dates that have been applied, and then we date by standard methods, we get quite different results. So we get different results, often get quite different results. Now, it's interesting, back when I was teaching physics in the mid-'80s, one of the textbooks on the principles of isotope geology that came out then was by G. Fourier, and he was one of the authorities in radiometric dating in the world at that time. And he actually points out a number of cases where radiometric data and dating is just wrong. And again, it's one of these areas that people have to be aware of. He cites a number of cases. For example, he cited studies that were done on some lava that was dated less than 1.6 million years, according to its position in the rock layer, and yet using the rubidium-strontium dating, it was dated at 773 million years. So there's
Or is it more?
1.6 million.
Oh, million. So
1.5 million.
Sorry, I thought billion.
And then it was stated at 773 million. So that's
a lot more.
Yeah.
Wow.
That's 700 times more.
That's huge.
And it gives another example of Upper Miocene to Pliocene lava, which was traditionally dated 5 to 9 million years old. And by potassium-argon, and dated at 31 to 39 million years old using rubidium-strontium. So we can see there that, and this is what you were talking about earlier, when we use potassium-argon, 5 to 9 million years, using the rubidium-strontium, 31 to 39 million years. So again, a huge difference there. Which date do you take? Well, the date that they take, if it fits closest one, they pick the one that's closest to the actual fossil record. So you can see there's a bias here.
Yes.
We can get a whole lot of different results. We're saying, the other ones must be wrong. We don't know why they're wrong, but hang on, we'll choose this one because this is closest to the one we expect to get.
Yeah.
A number of classic examples of this. Another case of some lava that stratigraphically was dated at Pliocene to Holocene, so that's current. That is less than 5.3 million years old, and it gave rubidium-strontium ages of 570 million years. So this should be only 5 million, but 570 million years with rubidium-strontium, and another method gave 870 million years. Another rock in the same age, so it should be fairly young, about less than 5 million years old, was dated as 1,500 million years old by rubidium-strontium. So these are, we could go through a whole lot of another rock that was assigned as less than 24 million years old, according to the fossil record, but dated as 1,200 million years old by rubidium-strontium method. Now, these examples that I've just read out are all from Theo's textbook,
Right.
Warning Students, that was published by Wiley and Sons back in 1986. And so, we need to understand this. And again, if we look, say, at some more recent data, for example, here in Australia, the Somerset Dam up in Queensland there's a Jurassic-Triassic intrusion that's supposed to be around about 220 million years old there. This is from the fossil record. And it gave potassium-argon ages range from 183 to 252 with the isochron dates, that's the accurate method, of 174 million years. So it's supposed to be 220. The accurate method gave 174 million years, and the error was only plus or minus 9. When they dated it with the rubidium-strontium isochron method, they got an age of 390 million years. When they dated using the samarium-neodymium isochron method, an age of 259 million years. But it's interesting, the lead method gave an age of about 1,400 million years, plus or minus 1,000 million years. So, again, so how old was the intrusion? 174 million years or 1,425 million years? These are the range of ages for the same intrusion. This is 1997 results.
Wow. And so we've got the same sample. We are applying different radiometric methods on the same sample, and we're getting a vast array.
This huge array. So if you're doing your master's thesis or your PhD or honours thesis on studying these rocks, the result that you would pick is the one that's closest to the fossil dating method. And how was the fossil dating method worked out? It was worked out by assuming uniform deposition of sediment over hundreds of millions of years that contradicts erosion rates, right? And plus the evidence for catastrophic path. So you can see we've got major problems, and yet these dates are put up on big billboards at national parks and all this sort of thing, and people, and they're so widespread, so ubiquitous, so to speak, that people have just assumed, these ages are all correct.
What is so puzzling to me is, in any other field of science or a scientific study, if you had data across the spectrum and then you picked and choose the data according to what fit a theory which you are aligned to, that would be looked down upon very much as you skewed the data. You're
cherry-picked it.
Yeah, and now you're presenting information that's misleading the public if it's related to a public issue. And that's like a big no-no for true science. And yet in here it's done, and it's just left, and it's considered normal. It's a huge contrast to me.
Yes.
To think
of course,
about that.
Most of the public doesn't know about this, and this is the sad part. And the people in museums, people working in other fields, they don't realise this is happening. One of the scientists I know that worked in this area, PhD from the University of Sydney in geology, did radiometric dating of uranium deposits as part of his doctorate. And work afterwards. And he found a rock, a piece of lava that had encased some wood. When they dated the wood, they got about 30,000 years. When they dated the rock, they got about 30 million years.
Oh, wow.
So you got so how old is it? How old? The wood's saying, hang on, it's only 30,000. The rock's saying, hang on, it's 30 million. These are rough figures. It might have been 37 million, But there was this huge contrast here. And this has happened too when they've measured rocks at the base of the Grand Canyon. and this sort of thing, depending on the method that they get. And they get huge ranges. You know, they might get a range of 600 million years difference between the different methods. And so what do? They settle on a method that's closest to the states.
So another question for you. What about for rocks where they already know how old the rock is based on history or something? So they know there was like the volcanic eruption 300 years ago. That means this rock is this age. Let's now test it and see if the dating lines up. How does that show
well,
for us?
That's a good question, and that's been done. For example, we have historical lava flows in Hawaii, and that were about 200 years old, something like that. And they were dated as 3.34 billion years old.
For a rock that's only 200 years old?
Yep. And the same dating lava from Vesuvius and all these sort of known volcanoes, when the lava flows historical, they get ranges from 100 million years old to 10,000 million years old, like 10.5 billion years old, which is older than the age of the Earth because it's only supposed to be 4.5 billion years old.
Oh, that's a bit of a problem, isn't it?
Yes, and if any of the listeners are interested in that, that was some work that was published. That work was done back in 1970. It's interesting, some work that was done at the Australian National University School of Earth Sciences, samples from the Mount Nauahoe eruption in New Zealand in the early 1950s, I think 1954. So those rocks were dated in 1999 or around 2000, something like that. So they're a bit less than 50 years old. And those results are very, very interesting. So they were analysed by the PRISE laboratory in the Research School of Earth Sciences at the Australian National University. The rubidium-strontium isotope gave an age of 133 million years, plus or minus 87 million years. The samarium-neodymium isochron gave an apparent age of 197 million years, plus or minus 160 million years. And the lead-lead isochron gave an apparent age of 3.908 plus or minus 390 million years. So nearly 4,000 million years from lead, around 200 million years for samarium-neodymium, and 130 million years for rubidium-strontium on rocks that were less than 50 years old. And similar data has been done on the lava from the Mount St Helens eruption. And again, they've got ages, hundreds of thousands of years for rocks that were about 20 years old when the work was done. So we can see here it's crazy. And that would be the way of validating the method, because you have a rock of known age.
Of course, it would be.
And you measure its age, and we get these huge ages for rocks that we actually know are young. And this is crucial evidence that we have major problems with the radiometric dating method. And again, we've got probably one of the best universities in Australia did this work to analyse these rocks here. And it's consistent. When they do analyse known historical date rocks that are only hundreds of years old or 1,000 years old, whatever, we get millions of years for the ages. And so, again, this should ring alarm bells when we're posting all these millions of years ages around, flaunting them all around. They're very inconsistent with what if we have a rock of known ages and analyse them, we get these ridiculous ages. This should be really throwing up red lights. We've got major, major problems with this method.
Absolutely. Time to completely reevaluate. That's what it's saying to me.
Very much
that
so.
kind of evidence.
Yeah.
Absolutely fascinating and important stuff. We're going to keep talking about this in the next session as we examine the question, how accurate is radiometric dating? Be sure to join us.